So I'm going to explain what exceptions are in Java, what try, catch, finally and throws does, and how we deal with problems in our Java programs. So I'm going to write a simple program to demonstrate this. Okay, so in the main method I'm going to construct the exceptions demo class, and in its constructor it's going to get two numbers by calling two methods, get number one, get number two. So I'm going to add these two together and store it in a total value and a total variable, and it's going to print out the total is total. So I'll just run that and confirm that it works. The total is 12. So number one was 10, number two was 2. So that's exactly what we would expect. But now let's think about something. Let's make it so that something can go wrong in this method. What I'm going to do is I'm going to prepare for, instead of getting the numbers from as a numeric value, I'm going to get them as a string value, because I'm going to convert this to read the input from the user, and we read input from the console as a string. So I'm just going to change this method, get number one and get number two, to return strings, and I'm going to return, instead of the double values, I'm going to return the number. And here I'm going to use the double wrapper class to say double value of, because we can only do arithmetic. If we want numeric arithmetic, we have to do it on numeric variables. If we add two strings together, we actually concatenate them, as we're doing here. But this should have the same effect. So let's see what happens. The total is 12, so it's done the same thing. The only difference is these methods are returning a string, and it's being converted to a number here. But now let's say we'll do the step that actually inputs these values from the user in a minute. But let's imagine that these are coming from the user now. But instead of entering 2, the user enters ABC, something that can't be converted to a number. So let's have a look at what happens here. Okay, this is an exception and this is a stack trace. What a stack trace does is it goes through the program. So the bottom of the stack trace has got main, which is our main method. That called the exceptions demo constructor, or the init in the stack trace. That called double value of at line 506 of double, which is in the Java code, in the Java code that we didn't write. And we can see that all the way through the stack of what called what during our when the execution of the program went wrong. So if we go down the stack trace and find the first line that we wrote, or the line towards the top that we wrote, exceptions demo line 8, it went wrong there, and the problem was a number format exception. That makes sense because we tried to format ABC as a number and we got a number format exception. So what we can do to get out of this is a try, catch, finally structure. So what we do, and let's just do it because it can happen to number one as well, we put try and then we open a curly bracket and we put in the block of code where this exception may occur. And then we say catch, and in brackets, number format exception, and we give that a name. And in this block, we do what we want to do if this exception happened. So I'm going to system out print line a number format exception occurred. So now let's see what happens when we run this program. It says a number format exception occurred. So it ran through this try block. It would have run that line. It would have run that line. Then the exception occurred. It would have jumped straight into the catch block, said a number format exception occurred, and that was the end of it. Now finally, we can add a finally block. It's optional. I'm just going to system out print line. I'm going to output there the finally block ran. And the finally block is always going to run. So if we run this program now, we've still got the ABC for number 2. So the exception is still going to occur. So we get a number format exception occurred. The finally block ran. If I correct it so that we put the 2 back into number 2, then what we get is the total is 12, the finally block ran. So what would have happened then is we ran through the try block, we got number 1, we got number 2, no exception has occurred, so we've carried on to the bottom. We then don't run what is in the catch block, and in the finally block we run that because we run that whether the exception occurs or not. So that's what try, catch and finally does. Now I'm going to, like I said before, I'm going to convert this method to read the value from the user. So I'm just going to change it to get number. And I'm going to system out print, enter a number. And then we can use a buffered reader. I've actually got some code here because it's difficult to remember how to do this. Buffered reader equals new buffered reader, input stream reader. What's wrong with this? Just need to import things. So we get a reader of system in, which is the console, and string number equals, this will be a string, reader read line, and then we want to return string number. Now we've got an error, a compiler error here. Now this is what we call a checked exception, because Java doesn't know what environment it's going to run in, so it doesn't really know whether this reader can read or not, because it doesn't know if there's a console or not. So if we hover over the error, we see unhandled exception type IO exception. Now an IO exception is a type of checked exception. It can be something like a reading of a file or reading of the console, as this is. We don't know whether the file exists. We don't know whether the program is running in an environment with a hard drive so that there can be a file. Or IO exceptions are things that we have to check for. So the compiler is forcing us to check this exception. So what we can do, we can put this in a try and catch IO exception. and that will fix the error because we've checked. We still need to definitely return something from this method. So every way through the method has to return a string or null. So by putting in this try block, we're demonstrating that we've thought about that problem and the compiler's satisfied. Now I don't want to do it that way. What I want to do is I don't want this method to deal with this problem. So what I can say is throws IO exception. And what I'm saying here is I don't want to deal with it here, throw it to the calling method. So now we've got an error up here, unhandled type IO exception. So what I can do here is I can, because I've already got a try block round here, I can catch it in this block. And I can output in the same way I did before, an IO exception occurred. So now we should be able to enter the number. So if enter a number 10, enter a number 2, total is 12, and the finally block run. If I run that again, I can enter a number A, and a number format exception has occurred. Now exceptions have a sort of hierarchy. We'll be covering in a video very soon about what inheritance means, but exceptions can inherit from each other, so there can be a parent exception. So an IO exception, if we look at the Java doc for that, we should be able to see that it extends, or that the parent class of IO exception is an exception. And if we look at the Java doc for number format exception, that's going to have a similar thing. The parent class for that is a legal argument exception. The parent for that is runtime exception, and the parent for that is exception. So what I can do is I can just catch exception, and that will cover both of the exception types. An exception occurred. So now we're saying we don't really care what's wrong, what sort of exception it is. It's just some sort of an exception. I'll put A there. An exception occurred. Now, depending on the version of Java you're using, if I put that back to number format, I can put, another way I can do it is by putting or. I can put or block like that, so I'm saying I want to catch either number format exception or IO exception here, and that will catch either one there. And one thing which is useful to do, I'm going to take out the finally block now, and I'm just going to say e.print stack trace. So if we look at the Java doc again, and we go to all exceptions, so the parent class exception, that should have a method print stack trace, which is really what the compiler uses. Where is it? Print stack trace, it's actually declared in the throwable class, and that will print the stack trace to the console, and that would be what the compiler would do. So now if we get an exception, we get the stack trace like we did before, and we can see where it is. But the fact is, we've thought about that exception. The fact that we've thought about it means that we may we know that the error may have occurred there. Because we've thought about it, we should deal with what to do with the rest of the program if that happens. So for example, I might return some sort of error or message box to the user to say that something's gone wrong. So that's Java exceptions. The thing to remember is we try things, and if they don't work, we catch an exception. We can have try, catch, and finally, and the finally block will always run. And the other thing is if there's a difference between checked exceptions and unchecked exceptions. Unchecked exceptions are ones that the compiler can't really see coming. We have to deal with that ourselves. If the compiler knows that it's a problem, like in an IO exception, it's a checked exception, and we're forced to do the either try, catch, or throw the exception. So that's how exceptions work in Java. Thanks for watching.